Today I want to show you the next step in this reverse engineering project. We're going to use Geomagic Design X to leverage the information from the 3D scanning activity that we did in the prior video. So we're going to import the STL file from that last step, and you see that when it comes into this, it's really in an odd orientation. The 3D scanner certainly doesn't know which way is horizontal and which way is vertical. For the time being, I'm going to turn off these principal planes that you see. I want to define a new plane and take advantage of the symmetry in the part. The first step in that is to use a tool called Auto Segment, which is going to analyze the part and specify the types of shapes that exist that make up the various features of this part. As an example, you'll notice here in a minute when this finishes that it's identified revolution, cylinder, cylinder, cylinder. Here's a plane. I have a plane on the other side. And the part has a lot of symmetry just by observation, and we want to use that to our advantage. So to get this part aligned, the first step I want to do is to define a plane using a selection that takes the average of two planes that exist on either side of this plane of symmetry. So we're going to select those two, create the plane, and there you have it. Looks like it's doing just what we might expect. Next I want to do is define a vector that corresponds with the axis of the cylinder as defined by this major feature of the part. You see it's done so. And we're going to define one more vector based on selecting this cylinder that's going to run in a horizontal direction after we orient things. And for the moment I'm going to turn off the mesh. I'm going to turn on the two vectors. Now I want to use a feature called Sketch. I want to put that on the plane that I just created. I want to convert those two vectors into line segments of the sketch. I'll turn those vectors off. I'm going to extend that line until it meets up with this one. I want to use this as my point of origin in the new axis. And just so I can see it more easily, I'm going to resize this line right here, so I can easily see them apart. I'm even going to change this to a construction line instead of a solid line. I'm going to exit the sketch. And now we're going to use a really wonderful tool within Geomagic Design X called Interactive Alignment. And it has already selected the mesh. I'm going to turn off those regions just so we can see the part more easily. We'll go to the next stage and specify plane that we just created as a reference element. Next we'll specify the solid line, which will become our x-axis, you'll see in a minute, and then we're going to define the origin as this point where those two lines intersected. We'll accept that, and now if we look at a front view, we see that the part is nicely aligned, although I have a personal preference for it to be oriented slightly differently, and we really no longer have a need for these items that we just created for alignment purposes only, so we're going to delete those. That allows us actually to use a transform function on this sketch. We're going to rotate it 180 degrees about the vertical axis, and that gets us to the orientation that I want to use for modeling this part. See that the front plane is nicely bisecting and serving as a plane of symmetry. If we do a left view, you can see that as well. We can flip it 180. So I have the part positioned, and we're ready for the next step. So with this part now aligned to the global axis as we want to have it oriented, we're ready to start creating the features of this part. And as you look at this part, There are really four basic features. There are two revolves, one at each end of the part. There's an extrusion, as I think of it, going down the main body of the part. And then there's a sweep that makes up the rest of this main body. So let's tackle that first revolve first at the right-hand side of this part. To do that, we're going to use a capability within Geomagic called Mesh Sketch, and it has grabbed the front plane that I had highlighted as well as the scan of the part, and it automatically generates polylines around the part where it bisected the scan data. I'm going to turn that scan data off for a moment. The first thing I kind of like to do is really just create some center lines for the global axes. It gives us a vertical and horizontal reference for perhaps other things that you'll see in a minute. Having done that, I want to create a best fit circle to the one that's shown here. And as you look at the details of that, we know that we want that aligned with the vertical axis. And I really like to use dimensions that are rounded, say, to a couple of decimal points. And in this case, looks like we're at 18.07 on that radius. So we've dialed that in, and we just want to go around the right-hand side of that vertical center line now and fill in the rest of the profile for what will become the basis of the revolve. So here's a best fit on the line. We'll give that a vertical constraint and then dial in so it matches the radius of 18.07. I believe that was the number. We'll check that radius. Yeah, 18.07. And we can trim that circle now so that we've got a nice beginning for the profile. We'll do a best fit on this line, and then there's a capability called Smart Dimensions. So let's check to see what this angle is off of the vertical axis. And this brings into question again, once again, what is the design intent? I'm imagining that the designer really wanted that to be a 40-degree angle. So we're going to dial that in. And let's go to this next line now, do a best fit on that line. We'll give it a vertical constraint as well. And that's measuring off the vertical axis 24.957. Let's round it to 96. Could be that he or she really wanted it to be 25. We don't know. We can always adjust that later if we want to. So let's do a best fit on this next segment. Use the Smart Dimension again off the vertical axis. 35 degrees and change. So let's make that 35, which is more likely what the designer intended. One more time on this next line segment. This time we'll use the Smart Dimension off the horizontal axis. 5 degrees and a little bit. So let's dial it exactly 5 degrees. And we just need to work on these rounds. So let's do a best fit on that arc, 2.3 and a little bit. So we'll use our fillet command, tell it 2.3, specify these two line segments, and it's in there. Best fit on the next arc, 2.68. We'll do the fillet command, 2.68. Specify the two line segments that arc is drawn in. We'll just continue to do the same with these others. Best fit is showing 6.54. Fillet command 6.54. That's looking good. Best fit on this arc 2.76. Fillet command 2.76. So we've got the profile nearly completed. There's probably an arc right here as well. So to think through that a bit, let's first off do a mirror image of that bottom line segment. We'll call this the line of symmetry, of course. Specify this entity. It automatically creates the mirror image of that line. Now we want to do a best fit on just a small portion of that arc, 20.22. Looks good. We'll put in a fillet, 20.22 between these two line segments, and we'll trim that arc and delete that line. So now we have the full profile for that sketch that will be used for the revolve about this vertical axis. We'll accept that. Go to our modeling tab, select revolve, select this sketch, identify both portions of that profile. We'll identify the rotational axis, and there we have it created. You can see that it overlays pretty nicely with the scan that we created in a prior step. So at this point I want to save that. It's always a nice thing to remember to do that. And we'll go on to the next revolve doing the exact same thing. In this case, I'm really just going to add to the same sketch that we created before. I'm going to turn the thing off, the STL file off. We'll do a best fit line here and a best fit line here. I'm going to give both of those a vertical constraint. I'm going to measure the distance between them along the x-axis. Well, actually, I'm going to first round them to perhaps more reasonable numbers. 9.4. Now I'm going to measure the distance. 57.03 between them. I'll do a line offset from one of those, and I'll say equals 57.03 divided by 2 to define the center line. I'll change that to a construction line representing the center line, and I'm going to just stretch that out by resizing it a bit. And so we'll do what we did before on the other sketch, or the other portion of the sketch. I'm going to do a best fit line, use smart dimension to see what that angle might look like. 4.35 we're going to call it. We'll do that again down here. Use the smart dimension command off of the vertical. 4.74 might actually be 5 degrees since they use 5 on the other one. We can change it later if we need to. And then we need to we need to do these fillets or rounds. 2.88 looks like a good number. Best fit on this 3.06, we'll round up to 3.07. And I'm going to trim that line back to the center, and then I want to mirror it about this vertical. And I'm going to ask for a best fit arc around, just using this portion of it, 25.5 we're going to call it. trim that arc, delete that line, and we're going to extend this line. So now we've got what we need to create the revolve around that left-hand side. Sketch disappeared on me for some reason. There we go. So I'm going to specify the same sketch. It picked up the vertical axis that we used before. So we're going to specify this vertical axis. And there we have it. Now let's turn on the scan again for comparison point. Making nice progress. So that's 2 of the 4 features. Next I want to try to do the cross section for this extrusion. In this case I've already got a plane on the principal axis for the right plane, normal to the x-axis. So we'll create a sketch using mesh sketch again, selecting the right plane. And we're just going to slide this arrow back to where it's nicely intersecting the profile of that part. It's going to project it on the plane that we chose. I'm going to turn off a couple of things so it doesn't obstruct our view. And so once again we've got best fit circle opportunity. And we know that we want that to line up with the principal axes based on how we did our original alignment. And this radius looks to be 16.04 if you round it to 2 decimal points. So that's what we're going to go with. Now I'm going to put a center line down through this. And we're going to do the line offset of 16.04 in both directions off of that center line. We can trim these 2 segments. We can trim that. And down here in the middle of the part we just need a horizontal line anywhere really to complete the profile. We won't really have to delete these, but it just kind of cleans things up a bit. Turn the sketch back on so you can see we've got a nice profile created there. So we're just going to use that sketch to do an extrusion. Specify the sketch. We'll key in a number just to start with. We'll change the direction. I'm going to drag this out of ways. Now as I turn on that the solid elements, I've got a lot of extra material here, so I think what I really want to do is just now transform that particular shape to the left in the negative x direction by a reasonable amount. Where we can go something like that. So the next step is to remove the excess material from this extrusion. I'm going to work on that right lower corner as you see in this current view. For the moment I'm going to turn off the plane. You can see that eventually when we create our last feature, this sweep is going to engulf this right edge. So I could create a surface and cut off that corner. Another way to do it though would just be to use the chamfer tool and sort of pick an arbitrary dimension for removing that material. I just want to make sure that the surface that is left is going to be completely captured by the sweep that I'll create with that 4th feature. So it looks like a setting somewhere, if I went too shallow, for example 25, and I look at it in this front view, I'm still going to end up with a little bit of material left that's visible. So if I go to like 30 millimeters on a 45-degree chamfer, looks like that should take care of it. And there we have it. So that leaves us with the remaining task of removing the excess material on this extrusion that you see on the left end. For the moment, I'm going to turn off the solid body, and if you just glanced at that end surface, it might be a plane. Turns out it's actually got a curve to it. So let's use the mesh sketch feature to figure out what that curve really is. I'll specify the front plane, and I'm not going to use it at its 0 position because that's really right along that parting line from the casting. I want to move it off of that center to pick up a surface that's right on the feature that we want to reflect. And there we have that. Let's turn off the STL file for a moment. Let's do a best fit arc on that line right there. I'm just going to dial in some more reasonable numbers here to do decimal points for the center point of that. Looks like -5 is good. The center point of that arc. And it looks like 161.8 for the radius. And now I'm going to put in a construction line here going through the center point of that arc. And I'm going to trim that arc, or that circle back. So it's just an arc, I don't really need that much for creating the cutting surface. Trim the circle. I no longer need those construction lines. Now I'm ready to use a revolve tool, except it's going to be a revolve tool to create a surface body. And something more like 10 degrees in each of the 2 directions is probably the right way to go. Let's turn back the visibility for the solid body. Surface body, and now we can use cut command. We're going to target that extrusion. We're going to use the surface body we just created as the tool, and there we have it. Now we can see from the part itself that we've got some rounded corners here. We need to figure out what those fillets should be. So we'll do that with another mesh sketch. This time we'll grab the top plane for our point of reference, and we can use it positioned just right there. We go in and look at this, do a best fit circle, 1.88 on that one. Let's look at the other corner, see what it looks like. Best fit circle on that arc, 1.48. So maybe it's somewhere between those two. Let's call it 1.75. Might be a reasonable design intent. Put a fillet on there of 1.75. Seems like that blends fairly well. Let's turn the STL file back off. So that brings us to the end of our third feature.
So now we're ready to work on our fourth feature, which is the sweep along that main portion of the body of this part. And we're going to do that by starting with to build a sketch for the profile that will be used in that sweep. So let me turn on that right plane. We're going to build the sketch on that plane. We'll use mesh sketch again. Turn off the solid bodies for now. And in this case, I want to move that profile away from the plane until it gets right about there, before it breaks over on this curve and before it gets too far down the path of the sweep. I'll turn off the STL file. I'll start with the center line to define principal axes again. And we'll do a best fit line on this portion of this curve as a starting point. Using smart dimension again. Looks like they probably intended that to be a 3-degree draft angle. Looks to be vertical. Let's go ahead and put a vertical constraint on that. 18.002 on X. We'll round that to 18. And best fit on this lower line. And then using smart dimension off the horizontal axis, we'll call it 11.4. I'm just going to trim these corners until they meet. We can add the fillets or rounds later. And I'm going to extend these until they intersect the vertical line. And then we'll use the mirror command, specify this vertical line as the line of symmetry, and then identify these curves to create the mirror image. And there we have the profile that we'll use to make the sweep. Now there's a set of interesting things going on with this sweep. I think we want to use the top edge of this part to define the profile of the path. So I'll turn that sketch off, turn the front plane back on, we'll select it, we'll do another mesh sketch. In this case, we're going to bring that profile out to get a little closer to the edge. It's looking pretty good. I think that's the line that we want to use to pull that profile through. We'll turn the mesh off again. And we'll go through a similar process. We're going to do a best fit line. Oh, I forgot to draw my construction lines here for the principal axes. So let's use smart dimension here on this to see, is this horizontal? What is this? Looks like it's about a 1-degree angle, so we'll just use that. Rounded it to 1. Next line segment here, smart dimension command, 26.69 roughly. Let's call it 26.7. Let's do a best fit circle, 23.6. So let's dial in a fillet there of 23.6. Looks nice. Looks like we have a line segment maybe down here. Let's see what that looks like. Smart dimension off the vertical axis. We'll call that 11.4 degrees. degrees. And we gotta think about what's the best fit circle for this portion. 21.6. Actually looks like it might be a little undersized. Let's make it 22, thereabouts. So let's do fillet. Let's gotta compare that with the profile. Looks reasonable. I'm going to extend that line segment down just a little bit, make sure that we get well into the middle portion of the existing solid body. And we're going to extend this to the vertical line. And now we have a good looking path to use for our sweep. So here we go with the sweep. Here's the profile, here's the path. Turn the solid bodies on. First glance, that looks pretty reasonable. This is interesting. It seems like there's something going on here with this part that's not everything completely square with the world. So let's do something here to find out, is this surface really square or is it doing something else? I'm going to save it again before I continue. And we're going to go to the region command again. As it finishes crunching, it says that's a cone actually on that side. Got a plane on this side. It certainly looks planar. Must be something very interesting going on at that point. Well, let's see what a plane does for this. So we're going to extract a plane. And how about that? If we go to a top view, exactly vertical. We can certainly see some angle going on here as well. So let's turn our solid body back on, which is another frame of reference. You can see that there is some angle going on there. So we want to trim this sweep to match this plane. So we're going to do a sketch using that plane. I'm just going to draw a big box, much bigger than it needs to be. I'll turn off the other portions I've created. And then I want to do an extrusion from that box. Doesn't have to be anything close to that far out. I'm going to use that just to shave off that edge to match the surface that exists on the actual part. And before I do that cut, I'm going to create its mirror image across the front plane so I can do both sides at the same time. We'll do a cut using these two as the tool, cutting that part. And there we have it. Now, that should be aligning a little more closely. We'll turn off the regions, the planes, and the sketches. That seems to be a nice fit. So we have the overall shape for this fourth feature, and we just need to add rounds at the four corners. We can get a sense for how to size those by looking at a sketch that we created previously. I'm going to zoom in and just take a look. Do best fit circles on these top two corners. We see 3.1 roughly on this side, just under 3.1, so 3.1 seems like a good choice there. Here we see 3.26. Over here we see
3.24, so let's use 3.25. So we'll do our top two corners first. We'll use 3.1. Okay, then we'll do 3.25 at the bottom. Turn our mesh back on. It'll seem like they blend fairly well. So let's look at the rest of these. We're going to need to turn on the rest of our solid bodies. And we're now ready to merge these together. Use the merge command. Have a single body, and what's left then would be some fillets in a few places to finish the part up. Let's do we kind of need to figure out what is this fillet right here going to look like. So let's do a sketch, mesh sketch, using the top plane. Bring it down pretty close to this bottom right here. Raise that up just a bit. And let's turn off the mesh and the solid bodies. Let's do a best fit on that portion of the curve. That looks to be 3.8. See how that looks. It feels like that might be a little bit big. Now let's try it. Turn the mesh on, see how that blends. Alright, let's use that. And from a prior sketch, you can get a peek at what that fillet should be down here. Let's do a best fit on this arc, 2.8. Let's go with 3. We can always change it later easily if we don't like that result. So we'll do a fillet and 3. Looks nice. Here we just need to do one more mesh sketch to figure out what that radius is up here. I'm going to turn the mesh back on, the solid body off, use the front plane. Turn the mesh back off, and we'll do a best fit circle on these two pieces. 3.5. Let's go with that. Don't even really need to save that sketch. We'll just use the 3.5 number. Let's turn the mesh on again for a final comparison.